Okay. So the first topic is static electricity by friction. Now we all know what friction is, right? Whenever you are rubbing your hands with each other or against each other, it is friction. Okay. Whenever you are walking, your shoes are having friction with the floor, right? Whenever the car is rolling on the road, it is having rolling friction. We already discussed about friction in the first chapter, so I think you have the idea. Now, if glass rod is rubbed by a piece of silk, okay, glass rod is rubbed by a piece of silk, then what will happen? Electrons start to move from the glass to silk. Now we know that in atom there are three particles. Okay, this is from chemistry. You should be knowing that is electron, proton, and neutron. Okay, now proton and neutron, they stay in the center, okay, at the nucleus, and the electrons, they orbit in the orbitals, right, around the nucleus. Okay, now electron can move from one element to another element when we rub a certain element with another element. Okay, so if a glass rod is rubbed by a piece of silk, electrons start to move from glass to the silk, from glass to the silk. Electrons will move. Okay, electrons will move from glass to the silk. Then again, so the glass rod is positively charged. Now this is very much understandable. Now in normal condition, what happens is all the objects are neutral. Neutral means equal number of proton and electron. Equal number of proton and electron, they balance each other. Now if you take some electron from here, definitely it will have some extra protons. Now okay, let us say it had 8 proton and 8 electron. Now if you take 3 electron from here, then it will become 5 electron, and as a result 5 electron will balance 5 proton. Extra 3 proton will be left, right? So this body will become positively charged. Positively charged. And this electron has gone to silk, right? It is same for silk also. Silk was electrically neutral. Electrically neutral means equal number of proton and equal number of electron. Now some extra electron has arrived, right? So those extra electron will make this one negatively charged. Negatively charged. Okay, so whenever we got to know this thing, that whenever we are rubbing two things together, one of them will become positively charged, one of them will become negatively charged. Let us look at another example. This happens because silk has more affinity for electron. Okay, electron affinity I am going to explain a little bit later. Let us take a look at another example. Okay, again, if a plastic is rubbed using flannel, now we are using plastic and flannel. Okay, now as we are rubbing, one of them will become positively charged, another will become negatively charged. In case of plastic and flannel, what happens is the electron comes from flannel to the plastic. So this one becomes negatively charged and this one becomes positively charged. I hope this one, up to this one, you understood. Now, all of you might be having this question in your mind, that how can we know that which one will become positively charged and which one will become negatively charged? It depends on what? What are the factors that decides that this one will become positive and this one will become negative? The deciding factor is electron affinity. The deciding factor is electron affinity. In Bangla, if I mention it for you, it says electron priyota. Electron priyota. Now let me explain this one using a practical example. Let us say there is a girl and two boys like the same girl. Now the girl will choose which boy? Both of them love the girl, but the girl will choose that boy who loves her more, right? So the boy with more love will get the girl. Now imagine the same situation in case of electron. Electron is the girl here, okay? And there are two objects. Both of them want to get the electron. But the object that has more electron affinity, more love, affinity is love here, okay? If here plastic has higher electron affinity than flannel. So that is why electron will come to plastic and it will become negatively charged. and else it has lost some electron, it will become positively charged. Similarly, it goes for glass and silk. Here, silk has higher electron affinity, so the electron will go to silk and glass will be positively charged and it will become negatively charged. Okay. Up to now, if you have any doubt, kindly raise your hand. Okay, Imon. Yes, Imon, I can hear you.
Sir, actually, I couldn't catch the concept. Can you just recap it?
Huh?
I couldn't catch the concept of this, means this electron affinity.
Okay, the concept is, in short, I will put it into a couple of lines. See, whenever you have two objects and you rub them against each other, one of them will become positively charged, another will become negatively charged. That means one object will lose some electron, another object will gain some electron. The object that gains electron will be negatively charged and the object that loses electron will become positively charged. Now, the question arises, it depends on what, that which one will lose and which one will gain. It depends on the electron affinity. All the objects on the earth have a little bit of electron affinity. Someone have higher, someone have lower electron affinity. Okay. Now, if I tell you that, okay, electron is wanted by one object more, another object less. So what will happen? The electron will definitely go to the first object, right, which has higher electron affinity. Higher electron affinity means this object wants the electron more than the other object. Comparison, okay, both of them wants, but one object wants more. It has higher electron affinity, it has higher weakness to the electron, so electron will choose to go to that object. So that object will become negatively charged and other object will become positively charged. If I compare between plastic and flannel, plastic has higher electron affinity, so electron is a girl and plastic and flannel, two boys. Now when this girl will see that this boy has more love for him, for her, then she will go to this boy and this will become negatively charged and this will become positively charged. Similarly, it goes for here. This is a girl, two boys. This boy has more love, so the girl will go to her, go to him, and it will become negatively charged and it will become positively charged. Clear this one?
Yes, sir. Thank you.
Okay. Then I saw Imrana also raised hand. Imrana, do you want to say something? Then unmute yourself.
Yes, sir, I understood. I mean, I had the same question as Imon.
Okay, fine. Then we can move on, right? Okay, kindly
Yes,
write whatever you wanted to write. If you have finished writing, then I can erase. This has been explained through a figure, that is figure 10.02 in the book. I think if you look at the figure, you will see that the silk has become negatively charged and the glass has become positively charged. And in case of plastic and flannel, flannel is positively charged and plastic it is negatively charged. Okay, I think it is clear now.
Sir? He's not hearing me.
Imrana, you want to say something?
Yeah, is there any way to know which one have more electron affinity or which one have less electron affinity?
This is a question that I was actually expecting from one of you. The thing is, we don't know. Okay, after we rub and it gets charged, then only we get to know that this has become negatively charged. So definitely this one has higher electron affinity. Or actually there might be some characteristic through which we can understand which one is higher electron affinity, but I don't know right now. Okay, as you asked me the question, inshallah I will try to know more about this one and get back to you in the next class, inshallah. Okay. Okay, so I can move on. Now the second paragraph, okay, below the figure. Now we can do an experiment. Suppose using glass and silk, we have positively charged two pieces of glass. Okay, this one actually is very easy to explain. Without reading the book, I will explain it on the board. See, I hang a positively charged glass. Okay, then I have another positively charged glass with me. Now if I bring this one closer to this one, what do you expect? What will happen? Definitely there will be repulsion. Okay, definitely there will be repulsion. Why? Because same charges, they repulse each other. Like a boy repulses a boy and a boy attracts a girl. Okay, we can understand using this analogy also. So this positive charge will repulse this positive charge and make it move in that direction. Okay, it will go in that direction. Okay, it is like this. I will show you with an example. See, let us say this is a positively charged glass and this is a positively charged glass. So if I bring it closer to this one, it will move away. It will turn in this way. Okay, so it will be, I can show it in this way, that it will turn in this way. Okay, now same goes for a negatively charged plastic. If I have a negatively charged plastic here and another negatively charged plastic, if I bring it closer to this one, then what will happen? Again, it will go away from this one, as there is some repulsion force. Okay, now what if I bring a negatively charged plastic closer to a positively charged glass rod? What will happen? Now it will want to come closer to this one. Okay, let us say this is the negatively charged plastic and this is positively charged glass. If I bring it closer to this one, it will want to come to closer to this one. You see, it is trying to, you will see some deflection. If you hang it through a wire, then you will see that it is moving. Okay, before you take it closer, it will be static. When you take it closer, then what will happen? It will move towards that. So we can say that there is some attraction force between them, right? So in these two cases, there will be repulsion. Okay, repulsion, because same charge. You can take notes. Okay, it's better to take notes. Same charge. Okay, in this case and in this case, but in this case what will happen? Attraction force will be there, because opposite charge. Opposite always attracts each other. Opposite charge. Okay, I hope this is very easy to understand. That's why I will just ask quickly. If you have any doubt in this one, kindly raise your hand. Imon. Okay. Yes, Imon.
That magnet also have the same property, right?
Exactly like magnet. I forgot to give you the analogy. Okay,
Just
not
one
pole
question,
attracts
sir.
south pole, but not pole repulses south pole.
Sir, when we just rub a magnet with a piece of steel or iron, so the iron also gains the property of that magnet for a few while. So does that iron gain some electron from the magnet?
Yes. This is a topic that we are going to study in the later part of this chapter. Okay, this is something called electric induction. Inshallah, we will study this one. Okay.
Sir, in such case, does the magnet lose some of its power, means attraction power?
No. Magnet, actually, here the objects that we are considering, they don't have any magnetic power, any repulsive or attractive power before the friction occurs. Okay, but magnet is different. Even if you do not rub it, it has got some attracting and repulsive force, right? So magnet is different. We are considering the normal objects which do not have any kind of attracting or repulsive force before the friction occurs. Okay, this is something different. It's similar to magnet in case of attraction and repulsion, but the basic is different. Okay, magnet is something, you don't have to rub, you don't have to make it have friction with anything. It will have an attraction and repulsion force, right? But in case you have to have a friction. Okay, this is the case of a static electricity. Okay, now let us see why this is called a static electricity. Okay, it is Salman, you want to say something?
No.
Then why you unmuted yourself? Okay, now let us take a look. Why this is called static electricity? The electron has moved from one body to another, right? But after that, it is not going anywhere until you do something, right? Let us say, let me explain it in this way. Let us say I have a body here with positive charges and I have a body here with negative charges. We know that the body will attract each other, but there will be no movement of electron. Okay, the electron will be static. It will be, saved here, and it will be like this forever. But if you make them any connection between them, like you can make them connected with a conductor, okay, so what will happen? Now this electron will flow, this electron will start move, and it will come here, and both of them will become neutral. How neutral? This had some extra electron, he gave away, so it is neutral. This had some lag of electron, he got some electron and covered up his lagging, and this is also neutral. Okay, so now in this case you can see that the electron is moving, and when the electron is moving, we call it current electricity. Current electricity. Okay, the one that we are studying. Okay, in this chapter we will not actually make any connection between them, so the electrons, what will happen? They will be where they are. So this is static electricity. The next chapter that we are going to study will be regarding current electricity, where we will see the electrons are moving when there is some connection made between the two charged bodies. Okay, this is also a charged body, this is also a charged body. The difference is that this is negatively charged, this is positively charged. Acha, I think I could make it clear that why this chapter is called static electricity, because there is no movement of electron, okay, after the bodies are charged. Okay. The next topic that we will study is called electric induction. Come to the next page. Electrical induction. Electrical induction. Okay. Now this topic is discussed through an excellent example, an excellent phenomena. Okay, we all have experienced this. You know, when I was in grade 3, one day my friend told me that, do you have a pen? I showed him my pen, and he said that rub it with your hair. Okay, I rubbed it with my hair, and he had some piece of paper in his hand, small pieces of paper. So he told me that bring the pen closer to the piece of paper. So when I took it, I saw something, magical, and it amused me to a great deal. So what happened? Without making a touch with the piece of paper, the papers were coming up. They were jumping. Okay, I know. I know for sure that all of you have done this thing in your student life till now. So why this occurs? Okay, now what is the explanation between them? The question that comes to your mind, I can guess that it came to my mind also, that I know that when two bodies are oppositely charged, if one is positively charged, another one is negatively charged, then there will be some attraction, right? Okay, now when I rub my pen with my hair, the rubbing, the friction is between my hair and the pen. So let us say my pen got positively charged, my hair got negatively charged. Okay, now this is a charged body, but when I bring it near to the pieces of paper, those paper are not charged, right? They are not, they did not have any friction with anyone, so it is neutral. So how come there is an attraction force between the neutral body and the charged body? You understand what I'm saying? See, we have a body here. Let us say this is positively charged, and I have brought it closer to a body which is neutral. Neutral means it has equal number of electron and proton. If it has 4 proton, then it will have 4 electron also. See, 4 proton and 4 electron. This is neutral. Okay. Now, why there will be some attraction force between them? Salman, why you unmuted yourself?
Yes, sir.
Mute. Okay. Now, how the force is generated? Okay. This is where the concept of electrical induction comes into play. Okay. See, these positive charges will attract all these negative charges, and all the negative charges will be accumulated here. What will happen? All the negative charges will get attracted by these positive charges, and they will be accumulated here. And what about the positive charges? We know that the positive charge will repulse the positive charges, and it will, due to the repulsion force, the positive charges will be accumulated on the other side of the body, right? Now can you see there is an attraction force between them? Now it is easy to understand. Okay, these positive charges are attracting these negative charges, and these negative charges want to jump to this body due to this attraction, right? It is like, if this is an area with full of boys, and if this is an area full of girls, what will happen? You know, they will want to break the barrier and get mixed to each other, they get to know each other, right? This is the human nature, right? We are talking about a normal case, okay? Acha. So what will happen? There will be a huge attraction force between them, and when you take this body close enough to this one, not making contact, okay? We are not making any contact in this chapter. So what will happen? When you take close enough, the attraction force will be high enough that this body will move. Okay, see, this is what happening with the pieces of paper. This is the pieces of paper which are neutral, and this is my pen, okay, which is charged. So when I take it close enough to the pieces of paper, as a result, what is happening in the pieces of paper? All the opposite charges are being accumulated on this surface, and the opposite charges are on opposite. The similar charges are on opposite side. So what will happen? There will be attraction force acting, and due to the attraction force, when it is large enough, the pieces will start jumping. Do you understand this one? So now, without making two bodies charged, see, we have only one charged body, one neutral body. Still, there is some attraction force. See, this is inducing this one. This is inducing this one. Now, what we mean by inducing? Let us say I like to play football very much. Not football, I like cricket, so I will use the example of cricket. I like to play cricket very much. I have a best friend, right, with me. So, due to my inducing, he also might get involved into cricket playing sometimes, even though he is not that much interested in cricket, right? If I'm very much fond of the play cricket, I'm always watching all the matches of Bangladesh World Cup and other tournaments. What will happen? As he's always with me, he's my best friend. He will also start watching this, right? Now this happens, you know, in every house. Every mother, not every mother, I can say 90% of the mother, Bangladeshi mother, they see that Hindi serials, right? Now, when a baby is born, he does not have any inclination towards this Hindi serial, but ওই যে মায়ের সাথে থাকতে থাকতে the mother is watching, so the baby also starts watching, so the baby gets induced, প্রভাবিত হয়ে যায়, okay, যদি বাংলায় বুঝাতে চাই, they get also induced. So this is what is happening. This is a charged body. It is inducing this one to become charged, and as a result some attraction is generated, and this inducing is called electrical induction. Whenever there is some charge involved, it will be electrical, and it is inducing, so it is induction. Do you understand the concept of electrical induction? If you have any doubt, please raise your hand. Mizan, you already unmuted yourself. You want to say something? Acha. Iman raised hand, so I will talk to Iman. Iman, any problem?
Sir, you said that there is equal number of electron and proton in the paper, and there is only some protons in the pen, right?
Yes.
But you said there is attraction force for which it is getting picked up, but in the opposite side there is some repulsion force also, right? So this couldn't pick up it.
The repulsion force, this will be, you know, the positive charges will be accumulated on this side. But which force will be bigger, do you think? Definitely this positive and negative are closer than this positive and this positive. See, this positive and this positive are at a greater distance, but this positive and negative are closer, so the force between them will be much higher. Actually, we know this from the Newton's law of gravitation. It is the attraction force between two bodies is inversely proportional to the square of the distance between them. So as the distance increases, the force, attraction force, goes down. So here the distance is less, so attraction force will be higher. Here the distance is more, so the repulsion force will be lower. So as a result, the attraction force will overcome or overpower the repulsion force, and the paper will start jumping. Did you understand?
Okay. Yes, sir. Thank you.
Okay. Anyone else have any doubt? Pamita Kosan has joined, but I'm not sure whether she is awake or. Okay, no problem. Maida, where is Maida? Maida. No, Maida is not there. Oh, she didn't even care to join and sleep. Some people I know, they joined and they are sleeping, but she thought, what is the point of joining if I'm sleeping? Very good. I appreciate this one also. Okay. Nice. So we can move to the next topic. Rubaiya, you want to say something?
No, sir.
Acha, okay, good. I thought I
Just laughing. Just laughing.
Yeah, you can laugh. Sometimes laughing in class is very necessary. Okay. Acha, okay. So electrical induction, I would like to request you to go through this part. Okay, whatever I said, whatever I explained, these all are written in details here. Okay, you see the comb in the next page. The comb example is given, and the electrical induction is explained. So I would like to request you to go through writing these paragraphs very well. And if you come across any doubt, kindly mark that line and ask me about this one in the next class. Okay, so this is about electrical induction. Now, come to page number 286. We will study the electroscope now. Electroscope. Okay, this is a arrangement of machine. I can see that 2 person have sent me message. Okay, Iman, who is this police? And Tamjid is asking which police. Kindly stop chatting between yourself, okay?
Okay, sir.
Okay. How many minutes left?
10 minutes.
10 minutes left, right? Okay, kindly give me a notification when less than 2 minutes left, okay?
Okay, sir.
Okay. Now, we will talk about electroscope. At first, I will show the mechanism, not mechanism, actually the structure of the electroscope. Then I will explain for what purpose we use this one. Okay, this is our electroscope, and in Bangla it is called Shornopath Torikbikon Jantra. Okay, knowing the Bangla one is important because sometimes you might come across some suggestion where the questions are written in Bangla. So that you don't get confused, I'm mentioning the Bangla name also. Okay. So I think everyone is in page 286. Okay, we are going to go through this one. An electroscope is a wonderful equipment for test of static electricity. That equipment is very simple to determine the presence of charge. Yes, for what we will use this one? The use of this one is to determine the presence of charge. Presence of charge. Use. Okay. Now, presence of charge means, let us say I give you a body and I ask you, kindly check whether this body is charged or neutral. Whether this body is charged or neutral. So, if there is any presence of charge or not, you can determine using this electroscope. Okay, that is the first use. So, it contains 2 light leaves of gold. See, these are the 2 leaves of gold. Leaves of gold, and they has to be very light and very thin. Okay, then these 2 leaves are connected to a metal disc by a highly conducting rod. This is the metal disc. This is the metal disc, and this is that conducting rod. Don't remove this. This is the conducting rod. So the leaves are connected with this metal disc through this conducting rod. Okay. Achha. Then the whole setup is kept inside a glass bottle. This is the glass bottle. I will mark it inside glass bottle. Okay. The whole setup is kept inside a glass bottle with a non-conducting stopper so that it can be seen from outside. See, this is a stopper or cork. We say cork, right? This is a non-conducting stopper. Non-conducting. What do we mean by non-conducting? It will not conduct any electricity. Okay, the electricity cannot pass through this one. Non-conducting stopper. Okay. Now then, what will happen? The whole setup is kept inside a glass bottle with a non-conducting stopper so that it can be seen from outside. Yes, the bottle has to be transparent so that you can see what is going on inside the electroscope from outside. Okay, but yeah, or anything else cannot touch the light metal lid. Yeah, it has to be completely vacuum. Yeah, cannot be inside this one. Must remember this one. Okay, you must make it vacuum inside. Yeah, cannot be this one. And from this one has to be tightly fixed. Okay, this mouth has to be tightly fixed. Why? We cannot let air come into the glass bottle and affect our experiment. Okay, now charging the electroscope. If I want to know the presence of a charge, what I can do, and there is another purpose. Let us say when I gave you the body and I told you find out whether the body is charged or not, you found out that yes, this body is charged. How you will find out? I will show you. But let us say you found out that you told me that yes, sir, this body is charged. Now I ask you, what type of charge is there? Is it positive or it is negative? Then there is some other question, right? You have to do another experiment. So electroscope will tell you actually this body is positively charged or negatively charged. So you can also determine the nature of charge of a charged body. If the body is charged, then you can find out whether it is positively charged or negatively charged. Okay, so this is our setup. Okay, this is an electroscope, and this is actually gold leaf electroscope. Gold leaf. Now, gold leaf electroscope. In case of gold, as gold is very much expensive, people are using aluminium also. You know that aluminium is very light in weight, right? And very available, not that much expensive. So if you use aluminium also, that is also okay. Okay, instead of gold, you can use aluminium. So this is the setup and this is the use. If you have any doubt here, kindly tell me because I'm going to erase this one. I'm having to look at the time again and again. Okay, 4 minutes, exactly 4 minutes left. Okay, so if you have any doubt, kindly tell me. Acha. I don't think there is any more doubt. So if I start the next topic, then I don't think I will be able to finish this one within today. So better you go through the pages 282 from 282 to 286. Better if you could go up to electric force. Okay, 287. Kindly read this paragraph. See, 287 page. This is electric force up to that. Up to electric force. Okay, if you could go through all the paragraphs and mark out all the doubts, then it will be better for me to discuss in the next class. Okay, so I hope your kind cooperation. And now if you have any doubt, ask me.
Sir, how are you gonna make the bottle vacuum? Even if we
there are so many mechanisms.
if we heat it will be enough.
There are pumps. Okay, if you fix the pump with this one, okay, motor. A motor can be fixed with this one, and the air can be sucked through this pump. Okay, and we can.
Will it be enough if we heat it from the bottom?
Huh?
Yeah, will it be enough if we heat it to make the air come out?
Heat.
Yep.
Heating. How heating will make this vacuum?
No. When we heat, right, all the air comes out from the bottle, right?
Not all the air will come out. Actually, what will happen? It is a convection process of heating. See, when you heat a liquid in a container, what happens? The bottom liquid, the liquid that are at the bottom part of the pot, they get heated first and then they go upward. And they send the cold water downward, they also get heated and then they come upward, then the upper one again go down. So as a result, what happens? The heat is transferred through the body. So this is true for air also. If you heat, what will happen? This air will go up and send the cold one down. then it will also get heated up. It will go and send the colder one down. So as a result, it will never be a vacuum. Okay. But still, as you said, I will try to take a look about this one, that by heating it, we can create any vacuum or not. What I said is from my common sense actually. Okay, this is what I know. Acha. So regarding the setup and the use, is there any doubt? Did you understand what I mean by presence of charge and nature of charge?
Yes, sir.
Okay, if nobody has doubt, then I think we can finish our class here, inshallah. And also this class I recorded. If anybody wants to see this one, anybody missed it, I will provide the video so that you can sit and...
Yes, sir, I need.
Oh, Rubaiya. Okay, inshallah,
Yes.
no problem. I will try to give it to everyone. Okay.
Me also need.
Yes, sir.
Thank you very much for joining.
Thank you,
Then
sir.
you want to say something? No. Okay. Thank you. I will end the meeting now. Assalamu alaikum.
Wa alaikum salam.